In this video, I'm going to show you how to do a straightforward, simple confirmatory factor analysis here in Stata using the sembuilder tool. You may want to follow along. If so, I've got a link to the data set down in the show notes. What I'm going to do is I have these 20 scale items, more or less fictional data, and I'm going to use that to create a confirmatory factor analysis based on a theory that I supposedly have ahead of time. It's really based on an exploratory factor analysis, but I'm going to assume that you have some kind of a theory or exploratory factor analysis done with a prior data set, something like that, that you want to test out here. In order to do it, the easiest thing is to use the sembuilder. You're just going to type, which stands for Structural Equation Modeling, sembuilder, hit enter. And of course, structural equation modeling can be done the same way. So I'm going to show you first how to use this sembuilder tool. I have a variety of tools here to the side for drawing a picture of your diagram. The arrow is just a select tool. This rectangle is for adding observed variables, okay? This other rectangle is for when we've got a generalized response model. That's for much more complex models than we'll be doing here, okay, in this video. And again, we've got oval for latent variables, and this double oval goes to the GSEM. Make sure your GSEM is not selected, or you'll have, it'll highlight if it is. It allows you to do these more complex things, but it will also give you an error when you're doing something simpler. We've got one-way arrows for paths, two arrows for correlations, and we've got this tool, which I call the spider tool, and that tool is useful for adding sections, measurement sections, a set of items that loads onto one latent variable. This is typically done with confirmatory factor analysis. So I'm going to be in just a minute using this tool primarily to create the diagram. You want to not mix it up with this tool down here. If you have really good eyes, you can see that in this tool, you've got a rectangle with rectangles. Everything's a rectangle. Well, this one, we've got an oval. The rectangle with the rectangles, this is used for adding like regressions. You can run a multiple regression here from the sembuilder, or simple linear regression, or all kinds of other models, path models and so forth, structural equation models. But this is for essentially where you've got some kind of a regression model where you have observed variables being predicted from other observed variables instead of trying to create latent variables. So right here, we're going to particularly be using this. This just allows you to text to the diagram. So if you click on that, then you can click anywhere in here and just add text. It's so that you can, put notes in or that kind of thing. And this allows you to highlight a section of the background that maybe you want to color a certain color or something like that. Because there's a lot you can do here to pretty up your diagram, and maybe I'll make another video on that. But in this particular case, what we're going to look at is just basically how to draw your diagram. And then across the top, you have a lot of options up here. Some of these, allows you to open a diagram you've already created, save one, print it. You can copy and paste the diagram to other places, and you can actually remove this grid background. So if you want to copy and paste your diagram into some kind of report or a thesis or dissertation or some other project, you can do that and make it look a lot nicer. You can really make the diagrams quite finished and nice looking in quality. And again, maybe I'll do another video on that. And of course, we have the undo and redo buttons. Now, right here, these buttons right here are sometimes very useful to me. These allow us to adjust the canvas size. So let's suppose you're doing a big, complicated model. In this case, I'm using one that just is going to be 10 items total, 5 items loading on one latent variable and 5 items loading on another latent variable for this example. And so we will fit fine in this size screen I have here. You can't resize the particular elements you put on here. You have to resize the screen around them to make it bigger or smaller. And to do that, you click on this one variable that's got the arrows pointing out of the box. And it tells you this is now 6 by 4 inches. I can make it whatever size I wish it to be. Hit apply, okay, or okay, either one. And now you'll scroll down to see that it's bigger. If I want to see the entire canvas I've created at one time, that's where this other box comes in handy. It's this fit in window box. It just resizes this, grid here so that the entire thing fits in my window, and you usually want to do that. So if you need to make your grid bigger, or for some reason you want to make it smaller, you do that first and then hit the resize button. And this is to run the model. There's also a variety of options, ways to do things with these drop downs here. I don't have to use them very often because generally these things give me what I want, or typing in code directly for most things that I choose to do. Okay, so right here, let's use this, what I call the spider tool. You want with the legs going upward, okay? Just click on it. Now on your canvas here, you're going to click approximately where you want the oval for the latent variable to go. So I'm going to put it right about here, and another window will pop open. And what you can do here is you can give this latent variable a name. I don't need a name for it because it's fictional data, but I'm just going to say latent variable 1. It was L1 by default. I didn't change it a lot, but you can give it whatever you want. You can go down here. You generally want to select the variables you want. Instead, you can just say, oh, I want 5, and then later you can connect the particular 5 you want. It'll connect to you can connect to particular variables in your data set. However, it's easier to just connect from the beginning. So I'm going to click on select variables. I'm going to click here, and the ones I want are number 1, 2, 13, 15, and I'm just single clicking on these, 20. That gives me all of those that I want to include, okay? Don't worry about these options for now. These things are rarely used. This is going to tell me which way I would say the spider legs point. So which way points towards your observed or manifest variables. And I'm going to have these point to the left. Okay, that's hard to change after the fact. So if I get this wrong, then I usually just delete what I put in and start over. Click OK. Now you'll see it pop up here. It's given it the name. I said LV1. It's got the names of my variables over here. You can see it's all highlighted blue right now, which allows me to to click and drag it. If it's not, you click that select tool up there, click and drag to highlight the entire thing. Make sure I've got this, click and drag thing set up. Make sure that, what I mean is that icon pops up with the 4-way arrows. And then I can click and drag and put it wherever I want on the screen to make it look nice. If I click off it, it is no longer highlighted in case I just want to move one element or piece of it. Like suppose that I want to have more space there. I can click and drag that and so forth. Now, at this point, when I've got this select tool highlighted here or chosen here, I can click on any item and I can change what variable it is. Okay, so if I wanted to, for example, use the option when I created it of just telling it I want 5 variables and not telling which ones, I can come to it after the fact from here. Through this interface, I can also put constraints on my variable. If you're a more advanced user of confirmatory factor analysis, that may be the kind of thing that you want to put on. Okay, I can tell it the error. Can you see that the error variances are off to the left here? I can tell it I want it a different direction. If it's not looking how I want it to do, I can put constraints on that error variance here as well. Okay, I can change the appearance of that rectangle. The way I would do it is I would check on this box, click on select custom appearance, and then there's various things I can change within here. And I'm not going to do that video. This video may do that in another video at some point. Okay, and this is if I want initial values and so forth that I want here. But I don't usually fiddle with those things. That's not commonly done. You can also double click on an actual line, the line that will represent the loading, and that may be useful if I want to change the appearance of it, or if I want to put a constraint or initial value on it, which is something more advanced that some people may wish to do. Okay, so that's my initial one set up. Let's go ahead and put in our other one. So I'm going to click again on this spider tool with the legs up. I'm going to click about where I want that to show up. I can always move it, so it's not critical. Just for the practice of using this box here, let's make it LV2. Again, you can name things whatever you want. You can select specific variables or just specify how many. I'm going to go down and just pick them right off. I'm going to single click on the ones that I want. Okay. Or you can type them in the box. You don't have to actually click on them. So if you know the names, you can just type them in as well. Okay, click OK. And you see that shows up, and look what happened. I forgot to tell it to put it to the right. So what do? I can manually move things around. It's not easy to do. What I would do in this particular case is just delete it. If it's all highlighted, you can just hit your delete key on your computer and it'll vanish. And then I do it again. Click on that. I'm going to right away change this to right so I don't forget. And I do that kind of thing often, so just be aware it's really easy to, of course, just delete it and redo it. That's a lot easier than trying to flip it around. And I'll put in the variables I want. Click OK. And now I'll just move it so it roughly lines up with the other one. Okay, the grid is helpful for that. If I click on the select tool and click off of that, it's no longer blue. I could stretch this one out so that it's similar to my first one. They're not exactly the same, but I can use the grid rectangles, the grids to make it match. Now the last thing I need to do for a confirmatory factor analysis is I always need to correlate my variables with each other, unless of course you're trying to test some theory about variables being perfectly correlated or otherwise correlation 0. If you do not correlate your variables with each other, it is going to try to fit the model, forcing this correlation to 0. You will probably get very poor fit. So that's not a recommended thing to do. And while it's, if I go select on this select tool again, while that's there, I can play with this, how this looks. That tool there lets me change the angle and direction of the curve. I can also, if I can hover and get my arrow, my cursor arrow right on that little teeny round awkward touches, I can move this so I can, refine exactly how that looks. I can double click on it so that I can give it a constrained or initial value or change its appearance, any of those types of things I wish to do as well. And the same is the case with the latent variables. I can constrain it with a certain mean and variance. It is going to be a by default estimate the model with a variance of 1. I'm going to, for each of the latent variables. Okay, and I can deal with the appearance and so forth. If I want to make the size bigger, I can change the name of it here, and if it's a big name doesn't fit, I can change the name of the oval, I can change the text and so forth within there. So I've got this all set up. Now the next thing to do is I'm going to run the model. So I'm going to click on this estimate button right here, and you'll see this pops open. I have these 3 options, okay? Maximum likelihood with missing values. So if you have missing values, then it will include the rest of the data for that observation, and they're just working around the missing values, and so it's slower. So the reason to click this first one rather than the second is just it's faster if you don't have any missing values. And then there's this asymptotic distribution free, which would be a great thing to do if, for example, some of your assumptions are violated. Now, there's some of the things that, this isn't a theory video, but generally you want to look at the skewness and kurtosis of every one of these variables. Extreme skewness or kurtosis is problematic, especially kurtosis. So that's something where you have that kind of violation of assumptions, you may want to use this. And I do have a video on looking at summary statistics where you can see how to find those, to look at those values. So that's something to be aware of. But to use this asymptotic distribution for you do have to have a very large sample, like 1,000 or thousands, for that to really work well. So it's not handy most of the time. More likely, you may want to end up coming over to this SE Robust and use robust standard errors instead if you are using this particular software, or else you may have to go something like M+ that has other estimation methods. Okay, so the other thing is it's got options for doing a group analysis. I may do a video on doing that at some point, but I won't cover that here, where you want to compare the model fit at various levels for different groups. This allows us to just limit the analysis to some group, or do it by, just do it within a certain group. Don't do a whole bunch with most of these options and so forth here. If you're an advanced user, these things may be helpful to you. But what I do typically do is click on the reporting and click on this display standardized coefficients and values. So I do typically click on that button so that I get standardized results, which are more interpretable. So that's the one option that I usually play with here, is adding that in. Other than if I'm missing values, I'll select this one instead. I don't if I do not have missing values, because it just makes the analysis slower. And how quickly this runs, of course, will depend on your computer processor and how quickly it can run. You'll see estimates showing down in this corner when it is finished. And you will see over here the basic estimates. Okay, so I've got all my loadings. And I've got my correlation. Again, this isn't a theory variable, but generally look for loadings above 0.7 as being very good, and above about 0.3 or 0.32 as being there is some level of loading. It's got intercepts here in the corner if you're interested in those, and it's got error variances over to the right. Now you will see here the one thing that I find is annoying is by default it will put the error variances to the right, and so here they are covered up by these arrows. You can't see them here. Now you will get them in table format. We'll look at that in just a minute back in the main Stata screen, so you will be able to see them. But if you want to use this, copy and paste this image somewhere, then that can be quite annoying. So what you want to do is, using this select tool, you want to go ahead and highlight all of these so they turn blue, and then when you get to that particular point they're highlighted, you can go up to Object, Properties. Okay, and what we're going to do is we're going to look at the appearance here. Click on Customize Appearance. Click on Set Custom Appearance. And when we get over here, click on the Results tab. It's a little bit tricky. Result 1 says Auto Error Variance. It's Result 1 that we want to deal with. So I'm going to now down here click on Result 1. And you can see where it says 3 o'clock. This 3 o'clock position is where it has put those results. I don't want it at the 3 o'clock position. I want it at the 9 o'clock position, or whatever position you want. Click on Apply, and you'll see them move right away. So that looks okay. And then I just hit OK all the way out of that interface. So that's a little bit tricky, and I'll have more detail on customizing appearance like that possibly in another video. But that should be helpful so you can at least see the results here. And now what I'm going to do is I'm going to minimize this window, go back to my main window, and you see that I have my results window here. And it starts up here. You'll see there's actually code that it uses to create this model. You could, in theory, type that out instead of using the sembuilder. It's going to tell me the number of observations used. It's going to give me this long table where I have the coefficient and intercept. So this is the loading and the intercept for every one of the relationships. So Here you see LV1 is latent variable 1, and you see that for the first 5 listed and the particular variables for the others. And in each case, you have the loading and the intercept given with their standard errors, z-values, p-values, and confidence intervals on the loading or the intercept itself. I typically, when I report, delete these constant lines out. I don't typically report those. In most cases, that's not information we care about. If you continue down, you will see the variances, those error variances with their standard errors and confidence intervals, and you will see that the latent variable variances themselves are set to 1. Here we have, this tells you which error they go to, and then of course the covariance between the two, which is really a correlation because I standardized this, so it's really a correlation, is negative 0.69 approximately with all of the associated statistics. Then at the very bottom of the table, it gives you the overall chi-square with degrees of freedom, so forth, and the p-value. And you will generally find, I didn't in this particular case because it happens to be a particularly good fitting model, you'll see in a minute. Typically that's statistically significant. We don't care because we don't expect in most cases statistical significance. Typically this chi-square is used to create the fit statistics that are more meaningful and useful to us. So it is useful simply because it is used to create the other fit statistics. To find those fit statistics, you're going to type in this command, estat estat, which stands for extended statistics. I think it's for statistics that you get after running something that applies to something you just ran. GOF stands for goodness of fit, comma, and then I'm going to put stats all in parentheses so that I get all of the statistics that are available here. Otherwise, you'll just get some minimal results. Okay, so I go ahead and I type that in, hit enter, and you'll see this table. This 41.78 is the same as up here. It's the chi-square that is used to estimate many of these other statistics. The RMSEA is very often reported. We want a low value. Below 0.05 is excellent, which we have here, and below 0.08 is adequate. So we're happy with that. And here's a confidence interval on it. Some people would say so long as that 0.08 is within the confidence interval, it's adequate. That's maybe a little more debatable point. And a p-value, the probably, whether it's less than there. And you typically report this main value here myself. These values are used for comparing models that otherwise would not be comparable, and that's beyond the theory of what we're going to cover here. CFI and TLI, I typically report those. In those cases, the closer to 1, the better. And above 0.95 is considered good fit. They both are above 0.95 here. Some people say above 0.90 is adequate fit, and other people say not. However, everyone typically agrees that above 0.95 is good fit. So everything here has good fit with this fictional data. Now, what do you do if you don't have good fit? This isn't a theory, of course, but again, there are a variety of reasons you may not have good fit. It may be that you have a small sample size, which I do here. It's only about 117. And with a smaller sample, a few people answering in an unusual way will throw off the fit. That's a possibility. It's harder to get good fit the smaller the sample size is. Another possibility is that there's items that should be removed because they're problematic in some way. Maybe the skewness or kurtosis is terrible, or maybe that item just doesn't belong on with it measuring the latent variable that you thought it measured. Which brings us to another possibility, is just your whole measurement model is wrong. Maybe, for example, there should just be 1 factor. Maybe there should be 3 factors. So maybe my theory is completely wrong. And the other thing that people look at is maybe there's some small tweaking that needs to be done by adding paths to the model. Typically by adding a one-way path, which would make a cross-loading, or adding a error correlation, and I'll show you how to look at that and how to do it, even though it's not really needed here. And to do that, we often look at modification indices, And the command is just estat again, but with M indices, mindices, which stands for modification indices. We'll hit enter, and we'll get a table of anything above that 3.84. And you can see there's a few. I usually ignore anything less than 10 myself, but none of these are suggesting a change is needed, and we do have good fit anyway. However, I'll still show you how to read it. This is basically saying if I add a path from item 6 to latent variable 1, right now this item 6 loads on latent variable 2, but if I add a path to latent variable 1, it'll improve that chi-square that is used to create the fit statistics by this much. So the chi-square will improve this much, which will cause an improvement to the actual fit statistics we care about. Same thing here. Okay, well here this is showing if I add a covariance between errors 2 and 20, then I will get this much of an improvement. And we would typically do that because maybe there's some unusual similarity between these two items. Maybe there's a wording that's similar. This often happens maybe when we have negatively worded items. Maybe these two are both worded negatively, and so there's a little extra correlation. But for some reason, there's a little bit extra correlation in how these items relate to each other beyond what is found in the latent variables you've included in the model themselves. So those are things to be considered. Now, in any of these cases, if you do add these cross-loading paths or these error covariances in, first of all, you want to add just one at a time and rerun the model, and then look to see whether your fit's good enough before you add another one. Even if 2 or more things look huge here, you would just do one at a time. And second, only add it if it makes theoretical sense. So look at the meaning of the items and see whether it makes any sense that, for example, you would add that cross-loading or that error covariance. You want to look at the meaning there. You can end up with problems where just due to flukes in your particular data set, and things, how people responded, where it makes you think that you should add a path that really isn't generally true. It's just due to flukes in how people responded this time. So it's typically advisable then to go collect a whole new data set to check to see whether that adding that particular path is reasonable also in the new data set. And then you would know that it really needs to be there. At any rate, I've got that information here. If I want to add particular paths and so forth, I'm going to go back to my diagram here, and I can add them in directly. Now, what I would do if I wanted to add a cross-loading, let's say I wanted to cross-load item 6 to this item, is I would just select on the one-way arrow tool here, start at the latent variable, and draw an arrow to that item like that. Okay, so that has that cross-loading in. It's all you need to do is add in that one-way arrow. I'm going to take it out. If you want to add in an error covariance, just click on the two-way arrows, and then you're just going to start at one. Note that I've got to hover till it's green, draw down, hover till it's green, and you will see it draws it. Now, if I go one direction, it's going to make the curve one way. If I go another direction, this time I went down up and made it the other way. If by chance it goes the way that doesn't look as nice to you, you can either delete it and redo it, or click on this select tool, and you can use this little tool here to adjust it so it looks the way you want it to look. Okay, so you can add in those error covariances and rerun it, see whether your fit is any better here. So that is the basics of doing a simple, straightforward, basic CFA model here in Stata.